Hi students, welcome to Narayana Virtual Classes. This is Venkat. Today the assignment topic is electromagnetism. This is assignment 26. Here mainly 5 questions are there. Let us go to discuss the question number 1. See the question number 1 here. Which law explained the direction of induced current in the coil? So you know very well how the induced current is produced. So how the induced current is produced explained by Lenz's law. What is the name here? Lenz's law. So Lenz's law explained that induced EMF produced induced current. You know very well, according to Lenz's law explained that when the magnet is moves towards the coil or away from the coil, here some induced EMF is produced due to change of flux. That induced EMF produced induced coil. So that's why which law is explained this one? This is Lenz's law. So this is the answer for question number 1. Next coming to question number 2. See the question here, give an application to law of electromagnetic induction. The main example for electromagnetic induction is induction stoves. The induction stove mainly it is working on the principle of electromagnetic induction. Here also same, when the flux will be changed inside the induction stoves, it produced induced EMF, finally produced heat energy. And second example for the electromagnetic induction is ATM machines. Especially we have to observe the debit cards, backside of the debit card we have to observe that magnetized regions. So when you have to keep that ATM cards inside that ATM machines, automatically it gain the information, details of the person who are the account holder is there, everything it is coming. So that ATM machines and induction stoves, these are the example for electromagnetic induction. Next coming to the third one, from the given figure answer the following questions. So see the first one, what will happen when the magnet pushes? See the picture here. See the picture. See here, this is a picture. What happened? Yes. So this is the picture. When a bar magnet moves towards the coil, what happened? First one is when a bar magnet moves towards the coil, here flux will be changed. The change of flux, when the flux will be changed here, the change of flux produced induced EMF. Due to induced EMF, when the magnet moves towards the coil, automatically here induced current will produce. That's why the galvanometer is deflection which takes place, means it is change the needle direction, means some deflection is takes place inside the galvanometer. So that is the option A. Coming to second B, what will happen when the magnet does not push? When the magnet is constant, there is no any movement means towards the coil or away from the coil, there is no any movement, means here change of flux, no change of flux, no change of flux, no change of magnetic flux. So when the flux does not change, that's why there is no current will be produced. That's why here the galvanometer there is no any deflections, galvanometer is constant. That is option, that is second one, B answer. Okay, next question is coming to fourth one. The fourth question is, your friend asked you to explain the working principle involved in a induction stove. What is your answer? Just now we discussed here the induction stove is main example for electromagnetic induction. See this is the induction stoves. Inside the induction stoves you have to observe that one coil will be. So when the current is passed through the coil, here the magnetic flux will be produced. When the magnetic flux will be produced, it generate current inside the coil. At the same time here the induced EMF, this is a pan, the induced EMF in the pan on the stove, and also this pan have infinite, due to infinite resistance, that induced EMF produced induced current, and same way that induced EMF it is generate heat energy. Why heat energy is coming? This is infinite resistance. The pan is there, the pan is infinite resistance. Finally, the heat will be generated. Okay, once again see here, first of all the coil, the flux will be changed in the coil. When the flux is changed here, automatically it produced induced current inside the coil. And the same way the induced EMF is produced inside the pan, automatically due to resistance, due to finite resistance, it produced heat energy. Okay, so like that the induction stove is produced by the principle of electromagnetic induction. So that is answer for question number 4. Next, coming to fifth question, how can you apply conservation of energy for electromagnetic induction? See here the picture, here we taken here one coil of wire. Here this is the current carrying wire. So here we taken one bar magnet. So the bar magnet moves, the bar magnet north pole moves towards the coil, current carrying wire. Here just you have to assume that the current is produced in the wire, the magnetic field direction is, current direction is clockwise direction. The direction is, if the direction is clockwise direction, one surface is act like a south pole, one surface is act like a north pole. So you have to assume that the north pole of the magnet moves towards the coil. Here the current will produce in the clockwise direction. In the clockwise direction. In that time what happened here, the south pole of the wire and north pole of the magnet both are attracts. When both are attracts, here there is no any external force here. There is no any electromagnetic induction here. That's why our assumption is wrong. This is wrong condition. So coming to here, when a bar magnet moves towards the coil, here what happened, that current is moving in the anti-clockwise direction. The current is formed here anti-clockwise direction. Anti-clockwise direction means one surface is act like a north pole and one surface act like a south pole, means right side is north and left side is act like a south pole. So when here north and north, the bar magnet pole is north pole and the wire having the one more magnet, means this wire is behave like a bar magnet. That's why here this north pole and the wire north pole and bar magnet north pole both are is repulse. When the repulse here produce, some force will be produced. Here what happened here? Force is produced here. When force is produced, automatically here some electricity, some current is generated due to electromagnetic induction. Due to electromagnetic induction, what happening here? Current will be generated. That's why by using of the magnet we are producing here current. So means due to that process is known as, that is law of conservation of energy, means the energy changes to one form to another form. By using of the magnetic force is converted to electrical force or mechanical force is converted to electrical force. So like that the energy is transferred. Okay, that is called conservation of energy of electromagnetic induction. So this is the answer for question number 5. I hope you understand. This is assignment. Next time we have to discuss with one more assignment. Until, keep smiling. Thank you.